Good morning and welcome to the second module of Theory of Machines. Before we go into the second module, let us briefly review what we have seen in the previous module. We have seen in the previous module that machine is a device which receives energy in some form and converts it into mechanical work. We have also seen the theory of machines, which is a natural extension of the subject engineering mechanics, deals with multiple bodies in contact and attempts to analyze the relative motion and the forces involved. With that said, let us briefly see what are the learning outcomes of the current module. Okay. By the end of this module, you will be able to learn, you will be able to explain what are the branches of theory of machine, and then we'll see what are the definitions of kinematic link and kinematic pair. So let us briefly start with the branches of theory of machine. As shown here, theory of machines is an extension of engineering mechanics, and it has two branches: kinematics of machines and then dynamics of machines. For quite some time we'll be concentrating on this kinematics of machines, and then we'll go into the dynamics of machines. Okay. Kinematics of machines deals with study of relative motion between various parts of a machine, and it does not consider the forces causing the relative motion. Whereas in dynamics of machines, we'll be studying the motion between the relative motion between the parts and also the forces that are causing them. So in some sense, kinematics deals with only motion, dynamics deals with motion and forces. Okay. With that said, let us briefly start with the study of kinematics of machines. Okay. The study of kinematics of machines begins with definitions of kinematic link and kinematic pair. We'll see those in the next couple of slides. Okay. We define kinematic link or kinematic element. These are used synonymously, kinematic link or kinematic element, to be a part of machine which has motion relative to some other part of the machine. Okay. Such a thing is called a link or an element, kinematic link or kinematic element. Okay. We see that kinematic link, it may be built as a single body, or it may be built by assembling several bodies in such a way that there is no relative motion between themselves. So we'll try to see a couple of examples of that aspect of a kinematic link. And in passing, we note that a link must be a resistant body, that is, it must be capable of transmitting the required force without appreciable deformation. Okay. And also we may note here that we assume the kinematic link to deform only in the desired way as and when needed. An example of this is a belt drive. In a belt drive, you have a belt flowing on to a pulley and then coming off of it and coupling another pulley. So while it is going over the pulley, the belt wraps around the pulley and deforms. At other instances, it is straight. That is what we are saying, is that we want the belt to deform in a certain way, and the belt is deforming. Okay. We'll try to see a couple of examples of kinematic links. Okay. We see that this kinematic link typically has provision for connecting to other rigid bodies in the mechanism, because ultimately we want to form mechanisms out of kinematic links by coupling links one after the other. Okay. So a link typically has provisions for connecting to other rigid bodies. Okay. Shown here is one representative link. Okay. Kinematic links come in different sizes and different shapes. This is one schematic of a kinematic link. You see a pin here and a hole here. These represent provisions for connecting to other kinematic links. Just to give you an idea, I'll try to show an all-round view of this link. I'm just trying to rotate the link over here. It's turning all round. So it has a thickness, it has a pin, it has a hole. Okay. This link as shown here is kind of shown to be floating in air. Such links which can move in all directions are said to have 6 degrees of freedom. 3 degrees of translational freedom, that is, it can move along x-axis, it can move along y-axis, it can move along z-axis, it can rotate along x-axis, it can rotate along y-axis, it can rotate along z-axis. That is, there are 6 different ways in which the link can move, and so we say that this link in space has 6 degrees of freedom. We'll briefly try to see one example of a kinematic link which is built as an assembly of other resistant bodies. This shows a drilling machine. I would strongly encourage you to go into your workshop and take a good look at a drilling machine, and in specific the feed handle which is shown over here with 3 little spherical balls attached. Again, I'll try to turn this whole body around so that you can take a look at it, and then we'll zoom on to this particular part. You can see the 3 links. This is what we are considering. You can see that it is made out of 1, 2, 3 and 4 parts. But once these parts are assembled, that is, these are screwed in or jointed or fastened in some sense, once they are fastened, all of these together become one link. As I said, I would encourage you to take a good look at the drilling machine. Such practical observations will increase the depth of your understanding. We'll try to see one other example that is of a connecting rod. You can see there is one part here, another part here. To assemble it, we'll bring them close. There are holes across this, okay, through which you can fasten them together. I would once again encourage you to go into your IC Engines lab and have a good look at the connecting rod. If you have a cross section of an IC engine, you can have a good look. Let me quickly try to turn this around so that you'll have a look as to where you can pass the screws. You will bring it closer and then put a screw here, tighten them from the other side. Once it is assembled, these 2 parts do not have relative motion with respect to each other, and hence they form a link. Okay. Once we see the definition of link, we will see the definition of a kinematic pair. Okay. As the word pair here indicates that there are 2 links. Okay. So as we guess, kinematic pair is a connection of 2 kinematic links. When we say connection, it in some sense indicates that both the links are constrained to have only certain types of relative motion. For example, a link floating in air, as we have seen, has 6 degrees of freedom. But once it is anchored or connected or constrained to be in touch with another link always, it loses certain degrees of freedom because it is connected to something else. Depending on the type of connection, only certain types of motion is permitted. So to sum it all, we'll say that a kinematic pair is a connection of 2 links so that they are constrained to have only certain type of relative motion. Such 2 links, they are said to form a kinematic pair. Okay. So to summarize what we have seen in this class, we have seen that in theory of machines you have 2 important branches, kinematics and dynamics. Okay. In kinematics we study only about movements. In dynamics we study about movements and forces causing them. We have seen that kinematic link is a resistant body of a machine which has relative motion to some other part of the machine. Okay. And when 2 links are constrained to have only certain types of motion, they are said to form a kinematic pair. Okay. Thank you very much for staying with me. If you have any questions, comments or suggestions, please do email them to theoryofmachinesselftaught@gmail.com. Thank you very much. Have a good day.